On number 25, we're finding the value of y in the same diagram that we were given for number 24. If you watched the video for number 24, I talked about how there's a key piece of information missing from this problem. We need to know that segment OP is parallel to segment NQ. And then by knowing this key piece of information, I know that this small triangle is similar to this large triangle by angle, since they both share angle M and corresponding angles are congruent. So now I can set up my proportions using those similar triangles. Now in number 24 we had two options on how to solve for x, but when we go to solve for y we only have one option. We cannot use the part-to-part relationship that we could use to solve for x. The reason is y is a side of the large triangle and it corresponds to 7, which is a side of the small triangle. So we can only use a small to large triangle relationship to solve for y, not the part-to-part relationship. So if I do small to large, I would have to put the 7 over y. And when I set up my second ratio, I need to do two sides that correspond together, and one's from the small triangle and one's from the large triangle. If you choose to use this side of the triangle, you're using a number you came up with. And so if you got the wrong answer for x, you're now going to have the wrong answer for y as well. So I would suggest using this side of the triangle over here since you're given these numbers 4 and 8. Now be careful because you want small triangle side to large triangle side. 4 is not a side of either one of those triangles. 8 is a side of the small triangle, and the large triangle, the side is 12. And so if we're doing small to large, we would put 8 over 12 for that side, not the 4. So now we can cross multiply to solve. 8 times y is 8y. 7 times 12 is 84, and we can solve for y by dividing by 8. And so we get y is 10.5, and since that terminates, the decimal answer is fine, choice A.